Bon matin tout le monde. Good morning everyone. I am Pierre Bellec. I'm a professor in psychology here at the University of Montreal, although I never really studied psychology, that's still what I do. Um, I'm going to give you a little bit of background of what NeuroLibre is. And really the goal is to achieve reproducible publications, not open publications, but reproducible ones. And it's a fairly old idea. I think many people were exposed to that concept through the work of Bucket and Dono. They were Stanford scientists, and they made a point that when there was a figure in one of their papers, people could reproduce that figure. So they had a toolbox for MATLAB. That toolbox was called WebLab. And WebLab had high quality tools to illustrate all of their research, alongside with tools to fetch data, open data, in order to reproduce their work. I was personally very influenced by this work because I don't know how to change slides on this. There you go. That's a book. I mean, that's a famous Japanese painting, which was used as a cover of a book by Stéphane Mallat, a French scientist. The book is called A Web-Led Tour of Signal Processing. It's one of the key references up to this date in signal processing. It's been cited over 30,000 times, and I've done a project course with Stéphane Mallat during my master. And what's notable about that book, I mean, it's fantastic content, but also all the figures are reproducible using WebLab. So couldn't find the number of figures in the first edition, but the second edition that came out in 1999 features 164 figures, and each of those figures were associated with a very short MATLAB code that would retrieve the data and reproduce the figure. So I think that really set a standard of what reproducible science could be, demonstrated it was very feasible because it was done, except you need an infrastructure to make it work. The other problem is that WebLab is a MATLAB toolbox, and MATLAB is a high-quality product run by a company called MathWorks, except you cannot share MATLAB because it's proprietary. You have to pay for it. So although the code was open and reusable, in effect, the science was not. Another key development that is really opening possibilities to do reproducible science is containers. It's hard to put a birth date on containers because really containers are an incremental evolution of the Linux kernel. The way containers work is really the way Linux processes work. However, about 10 years ago, some people figured out that those features allowed them to assemble a file that could be used to rerun a particular process, including all the code environment configuration of that process, which meant you could share entire scientific workflow through a single file in a way that could be easily reproduced in any Linux system. Soon after that, Microsoft figured out that this was gold, so they partnered with Linux and supported that feature. Apple did so too. So nowadays, it is relatively straightforward to deploy a container, a software container, on pretty much any operating system in a reproducible, fast, and efficient manner. So containers have already emerged as the de facto standard to share reproducible pieces of science. Now, a common concern that people raise about containers is that, oh, this is technology, and technology disappears fast. So if we use science to preserve, if we use containers to preserve science, will we lose access to those containers in a matter of years? I think this concern is not accurate, and I'd like to take a bit of brief time to do a detour to explain why it's incorrect. This is Shinobi. It's an arcade game. It came out in 87. I played it intensively from 89 to 90 as a kid in a bar. I sucked at it, and I was really frustrated. My entire pocket money went into that game at the time. So when I turned 40, which was a while back now, I decided to solve my childhood problems and become really good at Shinobi. So I played Shinobi daily for about a year, and I can tell confidently today that I'm pretty good at Shinobi. However, I didn't play Shinobi installed on my PC. I played Shinobi on that specific arcade game hardware, but I didn't know the arcade game hardware because it's pretty big and bulky and it's collector item at this stage. What I did is that I used my computer to simulate the hardware of that arcade game in order to play the very software that played on that hardware a while back. This is called emulation. And I mean, in part, thanks to gaming hackers, this is very common. And just as a fun fact to tell you what we can do today, this is a 4004 chip. This is the first commercial chip ever produced by Intel. It came out in 1971. And last week, a hacker called Dmitry Greenberg managed to boot the modern Linux kernel on that chip. Interestingly, that chip was really basic and did not have the low-level instruction that would allow him to boot the Linux kernel. So what he did is that he emulated another chip, the R3000, that actually came out in 1988. So he emulated a processor from 88 on a chip from 71 to run 2020-24 software. So people who are concerned about containers are wrong. My bet is that if there's sufficient value in containers, in hundreds of years or millennia, unless humans destroy the planet, we will be able to run containers fairly easily. And if we're talking about the horizon of decades, there is no concern. I am running decade-old container actually fairly regularly, so I don't really think this is a valid concern. Anyway, that brings us to the NeuroLibre. You're going to hear a lot more about how NeuroLibre came into existence during this session, both the human component on it, the governance, as well as the technological stack that allows NeuroLibre to exist. But after many years of work, I would say roughly 6 or 7, I'm going to give you a little overview of what the platform is, and I consider this as an official beta launch, which is weirdly exciting. So let's head to the NeuroLibre website, and I'm just going to try to make sure that our friend on Zoom sees the screen. Patrick, do people see the website on the screen? Do you know?
You have to transfer.
Okay.
How's your window? But then you're going to have to do it there too.
Okay. So I'm going to have to click on the big screen. It's going to be pathetic, just as a warning. This is NeuroLibre. It is a preprint server. Its interface is actually a clone of the Journal of Open Source Software. So you can log in there and submit a paper. To submit a paper, you need to point to a GitHub repository that hosts the code of that paper alongside some configuration file. We will evaluate that paper and reproduce everything in there. If we think this is good, we'll accept it as a preprint. Here you have 10 articles which have been now evaluated and accepted. And I'm going to look at one particular preprint, which is a companion to an article that is currently published in PLOS Computational Biology from my laboratory. And I'd like to clarify one thing. A preprint is typically something you put online early, and that is a lesser version than the published article. This is much better than the published article, and it's not even a competition, really. The published article has been scientifically evaluated, which is good, but that applies obviously to that content because it's the same. But that particular paper features a number of other things that is not on the PLOS Computational Biology platform. you have here a number of links to reproducibility assets. The code of the paper, the data of the paper, and the container that allows you to run that code have all been archived through the NeuroLibre platform, which is a data data sharing platform. So here I just moved to the container. So it's been properly archived. It has actually as a digital object identifier that is unique and will remain as long as internet works. The metadata of that DOI points to the DOI of the preprint, so everything is properly linked in a industry-grade fashion to the original published preprint, and we have that for all the assets. And these assets come together in a reproducible living article, which is here, which is an HTML rendering of the article using a tool that is called Jupyter Book. And if I go in a section, I have here the code to generate all the figures of the article. They're interactive, typically. So here is one of the published figures. But this is not just a static website. Through the Binder Hub technology, I can reproduce this article. So I'm going to go and activate an interactive session here on our own NeuroLibre Binder Hub deployment. And I do that typically having my coffee in the morning. I like to reproduce that paper. Just to remind me, this is not a dream. It actually is very real. It was a bit slow. I apologize for that. What we did here is start a new server, reproduce the entire computational environment, get all the data, and get ready to reproduce the figures. So let's do it together. I'm going to clear this notebook and just rerun it entirely. I cannot really read what I'm clicking on, but I believe it's doing the same. So here what it's saying is that, oh God, it's already done it. I would have liked to be there when it created it. I've reproduced the figure. I can actually just mess with it and try to rerun that code just to see if I broke it. But it won't start doing that before it's finished reproducing all the figures of the paper. So I'd say that's an improvement over WordLab. It took, 30 years, but it is an improvement. As far as I know, this is the first publishing platform that would allow you to do this. So this is really how it works. What NeuroLibre has built is a way to automatize to a very large degree ingesting this type of submission and posting all the artifacts online. So we have a little bot, RoboNeuro, that will automatically do the uploads on Genodo, generate the DOIs, run the code. We offer a test server to our users so they can check that everything compiles correctly before they even start a submission. So this is really production-ready infrastructure. It's not a demonstration. Now, I'd like to remind everybody why we have libraries in the first place. Libraries are not there to preserve science. Nobody cares about what old people did. At least I certainly don't. The reason why I want to have access to what they did is to reuse it, make stuff with it. There's a lot of good knowledge that the older people have created. So the more complete the record and the more we can extract from it. And it's not me saying that, it's the National Research Council of the USA. So that's what ChatGPT thinks a library should look like. But if you followed what I explained, I think really the future library, that's what it's going to look like. It's a bunch of containers, and those things contain living little digital animals. And they're not just like there for you to look at, they can get out of their little containers, talk to one another and decide to create flowers, for example. This is a little bit conceptual, but I think by the end of the session, you're going to see exactly what I mean by that.